Okay, class, so 3.3 example 3 is just using our properties of logs, and they tell us here that we want to rewrite this in terms of the natural log of 2 and the natural log of 3. But the basic thing they want us to do is they want us to break this down to our prime numbers, and then if we can work any of it out, we need to. So like the natural log of 6, well, I can break that 6 down. 6 is, what, 2 times 3? So I could really say, well, this is the natural log of 2 times 3. But remember, we also talked about that we can expand this because we know that when they're being multiplied, we can separate them into their own logs by adding them. So you get the natural log of 2 plus the natural log of 3. Well, we really need to check, can we solve the natural log of 2? Well, let's check. We know that if I say I've got the natural log of 2 and let's say it's equal to y, natural log automatically has a base of e, and so I can set this up in exponential form as my e to the y equals 2. Well, can you get like bases when you have e and 2 as the base? You cannot. So you can't do this on here, which means the natural log of 2 is simplified. All right, then we have plus, can I work out the natural log of 3? Well, so let's check that. So the natural log of 3 equals y. Remember, natural log has a base of e. So when I go to exponential form, I get e to the y equals 3. Can you get a like base with e and 3? You cannot. So that means you can't simplify that one. So natural log of 3 is as simplified as it's going to get unless I type it in my calculator, which we're not going to. So therefore, I can't do anything else, so that is my solution. Now, as a hint, notice both of these, the 2 and the 3, I could not work out. The only way you'll be able to work this one out is if you have an E inside that parenthesis up there. So, in just a second here, I'm going to alter example B, and we're going to try something a little different where we can see maybe it would work. So instead of doing this B that's written in our notes, that if you were in the class when we did this, we actually went ahead and worked that one out. I'm going to say, okay, what if I have log base 3 of this same problem? So 2 over 27. Well, first, they're being divided, and we know we can separate that by subtraction. So you have log base 3 of the top minus log base 3 of the bottom. Well, 2 is prime, so I can't do anything else with it, but 27 is not. So I'm going to see, well, how can I break down this 27? So I'm going to come over here, I'm going to do a factor tree. 27 is what? 3 times 9. 3 is prime, 3 and 3. So I can write 27 as 3 to the third. And remember, you want to go ahead and use exponents as possible. You could write it out as 3 times 3 times 3, but then you're going to have to you're going to have all those 3 things being multiplied, which means you're going to add them, and in the end they're going to be alike, so you're going to end up combining them and ending up with a 3 at the front anyways. So can you do anything else here? Well, you've got this 3 as an exponent, so we know we can bungee it. So you get log base 3 of 2 minus 3 log base 3 of 3. So we got to check and see, can we work out the individual pieces? Let's check this one. Log base 3 of 2, set it equal to y, and see if you can solve it. So you end up with 3 to the y equals 2. Can you get a like base with 3 and 2? No, you can't. So therefore, you can't do anything else to that. So keep it as log base 3 of 2. Then you've got minus 3 times something. So let's see. Can I work out this log base 3 of 3? Well, let's set it equal to y. And let's set it up in exponential form. So 3 to the y equals 3. Well, I need an exponent there, so it's a 1. My bases are equal, so I can get rid of them. So I find that the y is equal to 1. Well, remember, this log base 3 of 3 was equal to y, so that means this whole thing there is equal to 1. And then we can simplify this little piece here, so we end up with log base 3 of 2 minus 3 times 1, which is 3. So that is simplified all the way down. Now I'm going to add in a blank page here, and we're going to look at one more example. So let's erase this, and let me open up a blank page. All right, so what if I had something like, let's call this example C. So if I had the natural log of 4 over e to the 6th. Well, it's being divided, so we know that we can separate them by subtraction. So the natural log of 4 minus the natural log of e to the 6th. And then we've got that exponent, so let's go ahead and deal with it. So the natural log of 4 minus 6 natural log of e. Well, if I try to work out this natural log of 4, now remember I told you earlier that if it didn't have an e there where that 4 is at, you're not going to be able to work it out. But let's just go ahead and prove that. So the natural log of 4, set it equal to y. Remember, it has a base of e, so e to the y equals 4. Can you get like bases? Nope, can't do it. So leave it as the natural log of 4. Then you got your minus 6 times, let's work on this natural log of e. So same thing, let's set it equal to y. Remember, natural log has a base of e. So when I set this up in exponential form, I end up with e to the y equals e. Well, I need an exponent there, so since it's not written, it's a 1. Bases cancel, so y equals 1. And that's one of the things I told you that you might want to just start remembering is that the natural log of e cancels out. It is equal to 1. So you don't have to work it out every time because it's going to be something that we're going to use pretty frequently. So, but continuing on then, so we got the natural log of 4 minus 6 times 1, which is 6. And there would be my solution for C. I hope this helps, guys.